Hi engineers, today let's see one of the simple problem in differential calculus, that is second derivative test. The methods. What are the steps involved in the second derivative test? So what they will do, they will give an equation, that is f of x in the question, and they will ask you to find the 5 subdivisions. So let's see how to find that 5 subdivisions. In that, first one will be the CP, that is called as critical point. So first we have to find the critical point. So first they will give a equation, that is f of x, that will be equal to any function of x. So for finding the critical point, what we have to do, we have to find f dash of x. We have this equation, any equation of f of x. So we have to find f dash of. Next what we have to do, we have to find whether it is increasing or decreasing interval, whether it is increasing or decreasing interval. So for finding increasing and decreasing interval, we have to find what are the interval first. So how to find this is, we have to take a line which is from minus infinity to plus infinity, and then what we have to do, we have to mark the critical points. For example, if we have 3 critical points, we can mark 1, 2 and 3 critical point. Let us assume C1, C2 and C3 are the 3 critical points. Now what we have to do, we have to find the interval. We have to find the interval. So what will be the interval is, first interval will be minus infinity to critical point. In this C1, C2, C3, it represents C3 is greater than C2, which is greater than C1. So from minus infinity, the first point will be critical point 1. From this we have to take any point and we have to find the value of f dash of x, and then we can tell whether the point is increasing interval or decreasing interval. For example, we can take any point between this. So how to take the point is, you take a point in such a way that the calculation will be easier. Okay. So we have to take any point that is we consider as x1, any point that is x1. Then we have to substitute the value of x1 in f dash of x. So after substituting this, we will get some answer, any answer. So we don't care about the answer, but what is important is the sign, whether the answer is in positive or negative. If it is in positive, then the interval is increasing interval. If it is negative, then the interval is decreasing interval. So what we have to do, we have to write the next interval. So next interval will be between C1 and C2. Next interval will be between C1 and C2. We have to take any point between C1 and C2 and we have to substitute in f dash of x and check whether it is positive or negative. If it is negative, it is decreasing. And then we have to find the third interval. What is the third interval? C3 to plus infinity. We have to take any point, that is x3, between this two, and we have to check whether it is positive or negative. If it is positive, it is increasing interval. So for finding x1, so x1 should be between this two interval, and next point should be in between this two interval, and another point between this two interval, and another point between this interval. So before this, we should write C2 and C3. C2 and C3, we are finding another point. If it is plus, it is increasing. If it is minus, it is decreasing. So this is how we found whether the interval is increasing or decreasing. So first they will ask what are the critical points. Second, they will ask whether the increasing or decreasing interval. And third, they will ask the local maxima and local minima point and what are the values. So what we have to do, so we have to again differentiate that equation with respect to x, that is f double dash of x. We have to find what is f double dash of x. Then what we have to do, we have to substitute the critical points. If we have 3 critical points, we have to substitute 3 critical points, that is f double dash of, if it is any value, for example 1, we have to substitute 1 in the equation. If the equation comes negative sign, it means it is less than 0, we will get local maxima. In this it will be opposite. If it is negative, we will get local maxima, and if the value is positive, it is greater than 0, we will get local minima. So what this denotes is, if we substituting the critical point, it will, whether it can be local maxima or local minima. So these are the points. Next we have to find how much is the value. So what we have to do, we have to take our f of x. So we will substitute the critical point. See, in this case we will substitute f double dash of c1, similarly f double dash of c2, and f double dash of c3, critical points. So in the same fashion, in this we have to substitute f of c1, and next we have to substitute f of c2. So we'll get some values, some x, let's consider x5 and x6. So in this again we can do a check. What check we can do, that is, see, this should be maxima and this should be minima. So on this we can do a check, that is x5 should be greater than x6. So this is the third one. We are finding the local maxima or local minima. So these are the points and these are the values. Okay. Then next they will ask for the concavity. So concavity, what we have to do, we have to equate this f double dash of x to 0. We have to equate this f double dash of x, that is equal to 0, and we have to find the value of x. So if this equation is x to the power of 2, that is x square, so how many points we will be getting? We will be getting 2 points. So after getting 2 points, what we have to do, again we have to draw a line and we have to write minus infinity, plus infinity. We have to mark that 2 points for the concavity. Again what we have to do, we have to write the interval. For example, this is concavity 0.1, this is concavity 0.2. These are nothing but the roots of this equation. So next, interval, in the sense we have 1, 2, 3 intervals. We have to write what are the 3 intervals, that is minus infinity to concavity 0.1, concavity 1 to concavity 2, and concavity 2 to infinity. In this case we know that concavity 2 is greater than concavity 1. So we have found out what are the intervals. In the same way as we did for increasing or decreasing interval, consider the point. We have to take any point in between this for the first case, and in between this for the second interval, and in between this for the third interval. And what we have to do, we have to substitute that point in f double dash of x equation. And again, if it is coming positive, this concavity will be upwards. If it is coming negative, the concavity will be downwards. So that's all. If it is coming positive, the concavity will be upwards. So in this they can ask two things, whether they can ask only for the concavity, or else they can also ask for the convexity. Convexity will be opposite of this, this is concave and this will be convex from the top. So if they are asking for the convexity, it will be reverse the sign, it will be downwards. If it is negative, it will be upwards. If it is positive, it is downwards. So that's all. We have also found out what is the interval of concavity, and if they ask for convexity, we can also change the direction and find the convexity. And this is the fourth one, and ultimately fifth, they will ask for the point of inflection or inflection point. Point of inflection or inflection point. In this, what we have to do, we have already got the 2 points CC1 and CC2. So what we have to do is, we know what is f of x. So in this, we will substitute f of CC1, that is this point, and we will get some value. Consider this as x7, and again what we will do, we will substitute the value of C2 and find it will be x8. So finally the point of inflections are, how we will write is CC1, what was the value, x7, and CC2, what was the value, x8. Okay, so in this we are going to find 5 things. The sum is very easy. This is differential calculus second derivative test. They will give f of x, so and ask you to find critical points, increasing or decreasing interval, maxima or minimum value and points, concavity, inflection point. So first we have to differentiate this with a single time. We have to differentiate f of x, that is f dash x. We are going to find the equate it to 0 and going to find the critical points. Make sure if it is an x cube, it will be having 3 critical points. Then we have to find whether it is an increasing or decreasing interval. So before finding that, we have to find what is the interval. So interval will be minus infinity to the critical points and to the plus infinity. And for finding increasing or decreasing interval, we have to take any one point. So take the point such a way that it will be very easy for the calculation. And if the values comes positive, it is increasing. If the values comes negative, it is decreasing. Then we have to find local maxima or local minima. In this, we have to differentiate again with respect to x, that is we are going to find f double dash of x, and we are going to substitute the critical point in this equation. And if it in this case it is reverse, if it is minus, it will be local maxima. If it is plus, it is local minima. So this will be the points. What will be the values? The actual question, the f of x, what we are going to substitute is c1, c2, c3. So we will get some answer. In this we can do a cross check, that is maximum value should be greater than the minimum value. Next, fourth one is we have to find the concavity. So for concavity, the double differentiated equation, that is f double dash x, should be equated to 0, and we have to find the what are the points. So after finding the points, again we have to repeat this step of 2, that is minus infinity to infinity, and what are the 2 points, and you can write the interval. Take any one point from the interval, which will be very simple for the calculation. If it is positive, concavity will be positive. If it is negative, concavity will be downwards. If it is positive, concavity will be upwards. And in the final step, they will ask for the point of inflection. So we have already found out just 2 values, cc1, cc2. Just substitute cc1 in the given question, that is f of x, find a value, and substitute cc2 in f of x and find another value. So finally the inflection point will be the cc1 comma x7, and the another one will be cc2 comma x8. So finally you make a result and write all the 5 things. The critical points are just 3 points. Increasing and decreasing interval are, write the interval whether it is increasing or decreasing, and it is local maxima, what is the local maxima point and what is its value, and what is the concavity, whether it is upwards or downwards, and what are the inflection points. Okay, so make a ready-made answer so that it will be easy for valuation. So by solving this problem, you can easily score marks. Okay, so that's all for today. Thank you.